Assalamualaikum, good morning, and hello everyone. So far, I see there are six of you here. We have Lim, Sin, An from Empat. Okay, so where are the rest? You can type your name in the live chat as for attendance. Okay, before that, can you hear teacher's voice clear? Can you hear me clearly? If you do, can you say yes in the live chat? Okay, student, if you can hear me clearly, you please type yes. Okay, we have Jun Leong, okay, we have Go Ji Yi. Thank you very much for your response. We also have Marcus. All right. So good morning, everyone. So I hope you have took your breakfast, sit in the most comfortable way, and get ready with your module for 2.6, 2.7, and 2.8. Okay, so today is our extra classes for these three topics. So I hope you can finish within these 2 hours. So if you have any question, you can type your question in the chat, live chat as well. And for those who want to join me in the studio, you can click this button. Okay, so you can be in the studio with me. Siapa nak join cikgu di studio boleh click this button. Okay, this one. Okay, we also have Yu Cheng from 4 Arcade and Yin Sing. Alright, okay. So while waiting for the others, okay, so later you also can see the repetition for this class. Okay, it can be rewatched on the same link. So if you are ready and good to go, so let us take a look at our topics 2.6 first. So actually I have started with 2.6 in class before for both for arcade and for by jury. So let us see what are the important in your student into for two learning standards. Okay, the first learning standard, each and every one of you must know how to define force as rate. It is defined as rate of change of momentum. Alright? Okay. And then the most important is to solve any problem involving force by using the equation for force F equal to ma. Okay, so this is stated in Newton's second law of motion. Okay, we also have Kai Xian, Bing Chen. Okay, thank you for your present. Alright. Okay, student. It's considered as any pulling or pushing action. Okay. Any pulling or pushing action considered as force. Okay, you push something, you apply a force. You pull the object, you apply to that. Okay. Our situation, the situation involving force of this bus. Okay. Okay, this man is cycling, pushing the bicycle forward. Okay, this boy stop a moving object, apply an object to stop the ball. Okay, this man pushing a wall involve force. So what is force again? Push or pull action. And what type of force do we have? We have frictional force between the keyboard and the ground. Okay, this is gravity force attracting the parachutist to the ground, and this is magnetic force. Okay, this is applied force. We apply a force to an object. This is a buoyant force acting on the air balloon, so make it able to float in the air. And this is a tension. Tension is a force applied to a rope. All right. And this is a drag force. Okay, when the man the drag or instant on this shoot. And then we have spring force. Spring force is a force of so in physics, okay, for the full definition, force is defined as the rate of change momentum. Okay, again, what is force? Rate of change of momentum. Okay, and also a vector quantity. And this is the equation you can use to solve any problem involving force. F equal ma, where F is the force applied, m is the mass of the object, and a is the acceleration. And student, the acceleration will be in the same direction with the resultant force acting on the object. Alright? Okay. So if you look at this question, how does a force change the momentum of an a boss? This graph, the more interesting graph is a graph of acceleration. A graph of velocity against time, and the third graph is the graph of displacement against time. Okay. Okay, so the first graph is say the acceleration is constant. Acceleration constant means the object is moving with increasing velocity, right? And this is the activity in your textbook, which can use to investigate the relationship between force and acceleration of object, and also the relationship between mass and acceleration. Okay, this one will be conducted after the exam. Alright, we will conduct this experiment after the exam. Okay, so let's say we discuss about the result first from the activity. Let's say this is the graph that you get. Actually, you have do one experiment earlier involving ticker timer, right? Okay, but for that experiment, we only study the displacement and also the velocity and acceleration. Okay, let's say this is the pattern of ticker timer we obtain from this activity. Okay, so if you look at this result, okay, when use one elastic spring, okay, connected to the trolley, so this is the initial velocity. Okay, how we get 2.5, this is the length of the first strip, divide with the time, 10 ticks for each, so each tick 0.02 seconds. So this is the initial velocity of the trolley, 12.5 centimeter per second. And to determine the final velocity, you have to check on the last strip, length 5 cm, and this is the time with velocity 25 centimeter per second. So we understand this trolley is accelerate, moving with increasing velocity. Okay, and this is the time interval between 6 strip here for us to calculate the acceleration. All right, so the acceleration of the trolley when using one elastic string is 12.5 cm per second squared. Okay, so we fill up this table. Okay, and then we use 2 and 3 elastic spring. Alright, okay. So later you will do this after the exam. Okay, let's say this is the reading determined from this activity. So what can you see here? What conclusion can you make? Okay, so you can see that when the number of spring increases, the velocity also increases, and so do the acceleration of the trolley. Alright, so what can we analyze from this come out? Okay, from the result. So we plot a graph of acceleration against force. Force is represented by the number of string. Okay, this using one string, using two string, and using three string. So the number of string represent the amount of force applied to the trolley. So you can see from the graph plotted, acceleration is directly proportional to the force. Okay, and this is obey equation of F equal ma. All right, and for the second activity, okay, now we manipulate the mass, but we change the variable. Okay, uh, the force. Okay, the force we maintain. Okay, mean we are using same number of string. Before that, in the first experiment, we maintain the mass. We manipulate the force. Okay, now we maintain the force. We manipulate the mass. So this is to find the relationship between mass and acceleration. So you see, we are using two trolley as in the diagram. So we change the number of trolley here. One trolley, two trolley, and three trolleys. All right. And then this is the calculation. Let's say this is the data provided from the ticker timer. So again, we can determine the initial velocity of the trolley. So 5 centimeter per second, and the final velocity 30 meter per second. And then we calculate the time interval. This is the formula, remember? Why 6? Because we are using 6 strip here. And each strip took 0.2 second. Okay, so the time interval is 1 second from the first trip to the 6th strip. Okay, so by this, the acceleration is 25 centimeter per second. So we fill up the table. Alright. So we do the same way by using two trolley and three trolley. And from the findings, this is the reading. Okay, now you see that when the number of trolley increases or when the mass increases, you can see the velocity is decreases. Okay, the acceleration also decreases. So what conclusion we can get from here? Again, we plot a graph of acceleration now against mass. And if you remember, this is a graph showing that acceleration is, yes, inversely proportional to the mass. All right? Okay. So, if you plot a graph of reciprocal of m, so this will be the pattern of the, so it is a similar graph. These two graphs shows that acceleration is inversely proportional to mass when the force is constant. Again, this is obey equation of F equal to ma. So are you clear so far? Are you following me, students? You may give some response in the live chat. If you understand, you type 1. Okay, if you can follow me, please type 1 in the live chat. Okay, type 1, number 1. Okay, so what conclusion we can make from activity 2.13? So from here, we understand acceleration directly proportional to the applied force when the mass of the object is constant. Okay, thank you, Edolon, for your response. Yanling also, thank you. Shadow, who is this shadow? And we have two dots there. Can you identify yourself? Okay, and second, acceleration inversely proportional to the mass when the force applied of the object is constant. And when we combine these two relationships, so we come out with this relationship where F, okay, directly proportional to M and A. And when we change into mathematical expression, okay, so this is what we'll get. F equal ma. Alright. So what is A? Acceleration. V minus u divide t. So when you multiply with m, this will give you change of momentum. mv minus mu. Final momentum minus initial momentum. So when provided with t, so it becomes rate of change of momentum. So this is stated in Newton's second law of motion, where it says force is the rate of change of momentum. See? Okay. So what is 1 Newton mean, student, here? So 1 Newton mean this is the force produces an acceleration of 1 meter per second squared when apply on a mass of 1 kg. Alright? Okay. Then the unit for force is kilogram meter per second. So kilogram meter per second is kilogram on the mass. Meter per unit we represent in Newton, capital N. Alright? Okay. So next, okay, let us see what will be the effect of unbalanced forces acting on an object. So you will see there will be 5 effects. Unbalanced forces mean forces on the right is greater than forces on the left, or upward forces is greater than downward force. So what will happen to the object? Number one, it will move a stationary object, or it can stop a moving object. Okay. Second, unbalanced force will increase the velocity, or it will accelerate a moving object. Okay. Example, a car. When the thrust is greater than the drag force, so the car will accelerate to the front. Okay. And third, unbalanced force can decrease the velocity or decelerate an object. For example, when you press the pedal brake, so the drag force will be greater than the thrust force. So this will cause the car to decelerate and finally come to a stop. Okay, and number 4, unbalanced force also can change the direction of motion of an object. And last but not least, it can change the shape of an object. So these are all the effects of unbalanced forces acting on an object. Alright? Okay. Okay, then what about balance forces? What happens if the force on the right and left are equal? Or if the upward and downward force are equal? Okay, can you guess what will happen to the object? You can type your idea or your thought in the live chat. Okay, I would like to see some answers there. Okay, there are 2 effects of balance. What do you think the effects are? Okay, anyone? So far we have 19 students with me, supposed to be 65. So where are the rest? I hope they are not sleeping, still in the bed. Now it's already 9:19 a.m. Okay, anyone? What do you think the effect of balance forces acting on an object? Okay, object at stationary. Okay, very good. Okay, Marcus Lim. Okay, you are Marcus, right? Okay. Object remain at rest. Okay, very good. Min Min said object remain at rest. Okay, who else would like to give a thought? Object as stationary, object remain at rest. So this is the same answer, same meaning. So let us see. Yes, very good. Okay. Okay. Eidolon. Okay, remain stationary. Very good. Number 1, balance forces will cause the object to remain at rest or remain stationary. Okay, what is the second effect? Okay, what is the second effect? Just now you see, if the force is unbalanced, it will cause the object either to accelerate or to decelerate. Okay, now what happened if the forces are balanced? What do you think happened to the velocity? What happened to the acceleration now? Anyone? Okay, you can try. It's okay if you get it wrong, so we can clarify it for you. Okay, yes, very good. So the second effect, it will cause the object moving with uniform velocity or zero acceleration. So there will be 2 effects. Either the object remain at rest or stationary, and second, the object will move with uniform velocity, or we say moving with zero acceleration. Okay, got it, student? Okay, then. Okay, in our daily life, where is actually we apply force? Okay, so look at this GIF. This is the situation in the zero gravity in the outer space. Okay, inside a spacecraft. Okay, you can see what happen if there is no gravitational force? Okay, we have seen Earn with me in a studio. Okay, if you have your camera, if you have. Okay, if there is no gravitational force, students, so this is happen, things will be float in the air. All right. Okay, what about if there is no frictional force? What do you think might happen? Look at this Grand Prix racer. If there is no frictional force, see what happened to this cat. If there is no frictional force, what will happen to this airplane? Okay, so we will sleep while walking, whereas vehicle become non-stoppable. Okay, so in other meaning, yes, will not stop moving. Yes, very good. Then it will cause a disaster. So this is the reason why we need gravitational force. We need frictional force in our daily life. Yes, very good. All right. Okay, next. Okay, what about this? If there is no magnetic force, what do you think might happen to the compass? Yes, magnetic force. Yes, it's compass will be mentioned. So it cannot show direction. All right. Okay, so this is the importance of forces in our daily life. Okay. So this is the advantages of force. Okay, with the presence of electric force. So what can you do with electric force, student? You can iron your clothes, you can do your washing, you can watch television, and you can see me in the online classes now, live classes in YouTube. All right. So we are able to use electrical appliances which comforts our life. Okay, so this is electrical force. Okay, what else? Okay, now let us take a look at this example. Okay, so that is what force about. Okay, can we try to solve this together? I hope you are ready with your calculator so we can solve the problem together. Okay, the first question. We have a force acting on an object with a mass of 5 kg. Okay, and the first situation is say if the body accelerate uniformly, okay, from 2 meter per second to 8 meter per second in 2 seconds. Find the value of f. So this is the initial velocity u. This is the final velocity v. This is the time. You are given m. So you have to find f. Okay, can you find f? Those who have find f, you can type your answer in the live chat. Okay. Please work in on question 1a. Find the value of f acting on an object of 5 kilogram. Initial velocity 2 meter per second, final velocity 8 meter per second, and the time involved is 2 seconds. Okay, I'm waiting for your answer. So for those who are just joining us, you can type your name and your class in the live chat. So I will tick it as your attendance for today. Okay, Wenzan. Okay, what is the answer for A? Yes. 15 Newton. Okay. Can you hear me now? Boleh dengar cikgu? Okay, thank you. So the answer is 25 meter. Okay, 25 meter. Okay. So this is the solution for question 1A and 1B. Now cannot. Okay. Alright. Okay, next. Alright. Okay, next. Okay, question number 2, student. Okay, question number 2. Okay, question number 2. Okay, now we have force 60 Newton. Alright. Okay. Acting on a stationary object for 5 seconds and causes the object to reach velocity of 30 meter per second. Alright. So first you must find the mass of the object, and second find the displacement of the object. Okay, can you hear me now, students? Okay. Okay, try. Do question number 2. Okay, do question number 2. Find the mass and then find the displacement. Okay. So take your time for question 2. Once you've done, you can share your answer in the live chat. So this is similar to first question. Only that now you have to find the mass. Earlier you have to find the force. And B is the same. You have to find the displacement of the object. Okay. So I give you 1 minute to try this. So if you're done, you can share your answer in the live chat. Alright. Okay, welcome Po Eun, Jing Sheng, welcome. Welcome for those who are just joining us. Now we are discussing question 2 in a clone to formatting answer to be. Alright? Okay. So how to find the mass of the object? Okay, Joris also just joining us. Thank you, Joris. Good morning. Okay. So for 2A, this is all the given information. They give you F60, T5, U0. Why U0? Stationary object. Okay, and the final velocity 30 meter per second. Alright? Okay. So for the mass, what is the mass? 10 kg said by Wenzan. Displacement 150 meter. Let us check for the answer. For the mass, yes, it is 10 kg. Very good, Wenzan. Alright? Okay. And for the displacement, this is all the given information. We have U, V, T, and A. Okay, A is 6 meter per second. How is this 6 meter per second coming from? Datang dari mana? Okay, you can calculate. Okay, from now. Okay, we have Bing Chen with me in the studio. Okay, did you see Bing Chen up there? Okay, Bing Chen, if you have microphone, you can turn it on. Okay. So you know how to find the acceleration, right? F equal ma. Okay, so F is 10, F is 60, mass is 10, so acceleration is 6. Alright? Okay. So by this answer, 75 meter, the answer. Wenzan, can you calculate again the displacement? It is 75 meter. Okay, or you can use the next equation. This is the second option. You can use v squared equal u squared plus 2as. So you will end up with 75 meter. Okay, 7. Don't forget to divide by 2, Wenzan, here. I think you forgot to divide by 2. 75 meter. So who get 75 meter? As for the displacement, you can type 2 in the live chat. Okay, who gets 75 meter? Please type 2. Okay, at the live chat. All right. Okay, so can we go to the next question, student? Okay. So the next question, okay, this one. Okay, this is very easy. They give you an object with a mass for each, and there is force or forces acting on them. For A, single force acting in this direction. For B, there are two forces, 614 Newton acting in the same direction to the right. And C, we have 2 Newton acting to the left, 18 Newton acting to the right. Okay, and then for D, we have three forces, 5 and 5 to the left and 10 Newton to the right. Okay, so for here, you have to calculate the acceleration of the block. Okay, acceleration of the block. Welcome, Yisin. Okay, first, okay, this one, easy peasy, student. Find acceleration of the block when you are given with the mass and force. Okay, so I give you example for question A, then you please find for B, C, and D. All right. Okay, so we are using F equal ma. So for first, okay, F is 8, mass is 2, so acceleration is 4. Simple. All right. Okay. Can you figure out for B, C, and D? I give you 30 seconds for this question because it is just a straightforward and short calculation. Okay. Okay, so what is the answer for B? Let's call for G. Go G. What is your answer for B? And then we have who else we have here? Yanling. Okay, what is the answer for C? Uh, Zihui. What is the answer for D? Okay, can you share your answer in the live chat? The rest also can give your answer. Okay, so for question B, what is the answer, student? Yeah, Yanling 1.6. Okay. So for B, it is 4 meter per second. 6 and 14 in the same direction, so we plus them. Acceleration is 4. And for C, it is, yes, 1.6. So Yanling, you ask, Yu Cheng, sorry. Yu Cheng. Okay, thank you, Yu Cheng. Okay, I guess Yanling is it your mother's, or are you using your sister's or your mother's account? Yu Cheng. Okay. Okay, Wenzan give the full answer here. All right. A4, B4, C 1.6, D 0.4. Okay, so for D, yes, the answer is A for D. What is the answer for D? D is 0 meter per second. 5 Newton to the left, here also 5 Newton to the left, and here is 10 Newton to the right. So the forces are balanced. 10 to the left and 10 to the right. Okay, thank you. Say thanks to your mom. All right, thank you. So D, you are clear, right? Okay, maybe the arrow here is not clear. So here 5 Newton to the left, 5 Newton also to the left, and then we have 10 Newton to the, okay, I magnify the diagram for you. Okay, now you can see clearly the direction of the forces. 5 to the left, 10 to the right. So zero acceleration. The object move either with uniform velocity or it remain at rest. For A, the object accelerate to the right. B, object accelerate to the right. For C, also object accelerate to the right. And for D, there are two possibility. Either the object remain at rest or it move in a uniform velocity, either to the right or to the left. Okay, now we go to the structure question. Okay, this is example of question in paper 2, question number 5 and question number 6. Okay, let's do them together. So you are given two diagram here. Diagram A and diagram B. It shows a force acting on an object with the mass m. Okay, we refer to diagram A. Okay, what happened to the object? Okay, can you guess what happened to the object when a force of F apply to a trolley with a mass m? So what happened to the trolley? Okay, you can see here. So the trolley accelerate. Okay, it accelerate in the direction of F. Okay, so remember, the direction of acceleration is equal or same with the direction of the applied force. Okay, what about the second question? What happened if the force acting to F, okay, on the same object? Okay, now what happened to the motion, student? What happened to the motion? Okay, what happened to the motion? Okay, anyone would like to give a try? First, you see A, now it's double A. So we say, very simple, the acceleration increases. Okay, or you can say acceleration double. Okay, acceleration increases. Simple. Okay, next question. State the relationship between force and acceleration. This is very simple. We looked previously in the earlier slide before. How to say the relationship between F and A, student? Okay, can you say? Isin, what do you say? Joris, what do you say? How does F and A relate according to this situation? Jingsheng, you want to give a try? Poen, Jiaxin, Bingchen. So from here we say A is, yes, A is directly proportional to F. Okay, A is directly proportional to F. Okay, this one also can. Okay, the higher the force, the higher, but normally this is the statement for hypothesis. Okay, this is the format for hypothesis. Okay, for relationship, normally we say A is directly proportional to F. Yes, we mean. Okay, this is correct. It's not wrong, but this is more to hypothesis. Okay, are you clear now? Okay. Yes, A directly proportional to F. Okay, next question, student. Okay, now we have diagram A and diagram C. Okay, so what happened to this diagram? We maintain the force. The force is the same, 1%, but now we double the mass. Okay, we double the mass and see what happened to the acceleration. Okay, so what happened if the same force acting on the mass of 2m? So what happened now? Same force but apply to increasing mass. So you can see what happened to the acceleration. Yes, so we say acceleration decreases. So can you state the relationship between M and between mass? This is bahasa Melayu, supposed to be mass, M and acceleration. Yeah. Yeah, deceleration is correct. Okay. Okay, acceleration decrease. Yes, very good. Okay, acceleration decreases. So what is the relationship? So for here we say, okay, we say A is inversely proportional to M. Alright, A inversely proportional to M. Okay, A inversely proportional 2m. Is deceleration correct? We didn't say deceleration. Double dot. Okay, we say acceleration decreases. It still accelerate, but the magnitude is lower compared to A. Okay, yes. Okay, so I hope that is for question 2. Okay, I hope you are clear with question 2. Okay, now we move to question 3, student. Okay, we move to question 3. Again, this is example of SPM format paper. Object, now mass 2 kg, is pulled on the floor by a force of 5 Newton with constant velocity. Okay, constant velocity. So constant velocity means zero acceleration. So when zero acceleration, we understand the forces acting on the object is balance. Okay, balance. So the first question, what is the frictional force between the object and the floor? Okay, ini tak perlu kira. Actually, you don't need to calculate this. The answer is readily there. You pull an object with 5 Newton. It moves with constant velocity. So what is the frictional force between the object and the floor? Okay, anyone? So if you draw the situation, this is the floor, we put a box here. So you pull with 5 Newton. Okay, and this is the frictional force. Okay, what is the frictional force? So that it move with constant velocity or zero acceleration. So this means the forward force and the backward force is equal, is the same. Am I right? So the answer is 5 Newton. Okay? The frictional force equal to the applied force. So answer 5 Newton. You just write there 5 Newton enough. No need to write this all. Okay, just write there 5 Newton. N must be in capital. Okay, please remind N must be written in capital. Okay, in the exam. Sekarang tak mengapa, maybe you are not free to put the cap lock. Okay, but in the exam, please write it in capital. Okay, negative 5 Newton. Okay, 5 Newton. Alright, okay. Okay, then negative to show the direction to the left. Okay, now calculate the acceleration of the object. It is now pulled with 17 Newton. Okay, now calculate, student. Find the acceleration. It is now pulled with 17 Newton. So just now here we have 5. Now we change to 17. Okay, 17 Newton. Earlier we have find this. The frictional force is 5 Newton. Okay, so now find the acceleration. Can you find them? Okay, now here is 5, here is 17. So what is the acceleration now, student? Okay, so this is 5 Newton, the frictional force. 17 Newton is the forward force. So it has a net force of 12 Newton. Okay, so 17 plus 12. So by this now the acceleration is 6 meter per second squared. Okay, please don't forget to write the unit as well. Okay. Okay, so I guess most of you are clear with this question. So we move to the next one. Okay, number 4. Okay, number 4. Now we have a bus. 2000 kg. Travel with a uniform velocity 40 meter per second with this distance 2500 meter before it comes to rest. Comes to rest mean the final velocity is yes, 0. Very good. So you have to find the average deceleration, average force applied by the brake to bring the bus to a standstill. Okay, how to find average deceleration. Alright, okay, so how to do? This is all the given information. S, U, V. So you have to find A. So here you can use linear motion equation. Okay. Anybody printed out the formula list I gave you before? Ada siapa print keluar tak? Formula list yang cikgu share dekat Telegram group. If any one of you printed it out, can you type 3 in the live chat? Ada tak siapa yang print keluar? Actually, you can print them out for your reference. Tapi masa exam during, okay, because all the formula masuk formula dalam bilik exam. It is forbidden. Alright? Okay. As it is provided in paper 1 and paper 2. Okay, so you can print out the formula for using them at home when you A student. So we can use this equation. V squared equal U squared plus 2AS. So you just do the substitution. V0, Y0 come to rest finally. U40. Okay. So this is the displacement. This is 2,500 given. 2,500. Okay. So by this answer, negative 0.32 meter per second. So the deceleration of the bus, negative 0.32 meter per second. Okay, now how to find average force apply. Okay, so for here we apply F equal MA. F equal MA. So M is 2000. Acceleration we calculated earlier. Yeah, so the answer negative 640 Newton. Negative mean because we apply the brake. Okay, so we apply a brake force to stop the bus. So that's it's mean by the negative sign here. Negative 640 Newton. But what happened if you didn't write negative there? Is it wrong? Actually, no problem. It is still accepted. Okay. Okay, next. I think this is the last question for 2.6. Okay, last question for 2.6. This is SPM past year question. Okay, SPM past year question. In paper 2, section A, question number 5. Alright. So you are given two diagram. It shows a cyclist. Okay, there are two cyclists in 5.1 and in 5.2. Can you see any difference in these two diagrams? It say here diagram 5.1 show two cyclists and the bicycle reach the distance show in 3 seconds. So here they reach the distance in 3 seconds. Okay. And diagram 5.2 shows only one of the cyclists is cycling. Okay. In 5.1, both of them are cycling. Okay, so this represent the forces applied. But in 5.2, only one is cycling. The other one at the back is relaxing. Alright. And here they reach the destination in 7 seconds. Mean they reach the destination later. In 5.1, they reach the destination in 3 seconds when both are cycling second. Okay, the first question. Can you name the force acting between the bicycle and the road? Okay, anyone? What is the force acting between the bicycle and the road? Okay, anyone? Okay, what is the force acting between the bicycle and the road? Actually, you can write to answer that. The first one is frictional force between the road and the wheel of the bicycle. And second, you can also say gravitational force. Yes, Ming Ming, very good. You can also say gravitational force. Okay, mean the weight of the bicycle. Alright? Okay, good. Okay, next, student. Okay, next question B. Okay, question B, you have to make comparison. Okay, later in exam, you also have X. Okay, compare. Number 1, observe both diagram. First, compare the forces applied by the cyclist. So compare the forces in 5.1 and 5.2. So how we compare the force? Which one greater? Which one lower? Comparison. So which force greater? 5.1 or 5.2? And how to write, student? Okay. So you can say 5.1 greater than 5.2. Okay. Now we are comparing the force. So force in 5.1 greater than that in 5.2. Or you can use the mathematical symbol as well. 5.1 greater than 5.2 and vice versa. 5.2 less than 5.1. Okay, so this is how we answer a comparison question. Okay, next, compare the time taken travel to the same distance. Remember the time just now, 5.1, 3 second. 5.2, 7 second. So how we compare the who's longer, who's shorter? Okay, so what is your answer? Comparing the time. So how to write? So you can say 5.1 shorter than 5.2. Okay, 5.1 less than 5.2. Or vice versa. 5.2 greater than 5.1. 5.2 longer than 5.1. Okay, here you can write 5.2 greater than 5.1 in terms of the time. Okay. And third, based on your answer in B2, this is B2, compare the acceleration of the bicycle. Who do you think have a higher acceleration? 5.1 or 5.2, students? Come on. From the time stated, who having higher acceleration? 5.1 or 5.2? Anyone? Oh, siapa lagi cikgu? Who else I didn't call yet? Uh, Marcus? Bing Chen? Okay, anyone? Okay, 5.1. Jory say 5.1. Ella also say 5.1. Okay, let us say. So, yes, 5.1 greater than 5.2. Okay, so 5.1 greater. When we compare, you must write both. 5.1 greater than 5.2. Okay, 5.1 greater than 5.2. Or vice versa. 5.2 less than 5.1. Alright? Okay, very good. Okay, now the last question. Relate forces apply by the cyclist to the acceleration of the bicycle. Okay, what is the relationship between force and acceleration? Okay, this is similar to the previous question. Relate F and A. So what is the relationship, student? Yes, very good. So we can say, okay, directly proportional. F directly proportional to acceleration. Force directly proportional to acceleration. Or you can say force increases, acceleration increases. As I say, this is more to hypothesis, but it is not wrong if you write them this way. Tak ada masalah. Boleh dapat markah yang sama. Force increases, acceleration increases. Or you can say force greater, acceleration greater. Force higher, acceleration higher. Or we say force directly proportional to acceleration. Alright? Okay, so I hope you are clear with this question. Oh, ada lagi. A few more at the back. Okay, now name physics law involved in 5B4. Which law say that force directly proportional to acceleration? Can you name the law? Okay, which law? Newton first law? Newton second law? Newton third law of motion. Which one? Name the physics law involved. So the law is, yes, very good. Newton's second law of motion. When they ask you for law or principle, it must be written in a proper way. Newton's second law of motion. Okay? Okay, now this is application. This is K-BAT question, question D. What happened to the acceleration of the bicycle in 5.1? So you see 5.1 only. Don't look 5.2. Forward. Okay, now what happened to the acceleration? What do you think happened to the acceleration when both cyclists bend their bodies forward? Okay, any changes happen to the acceleration? Will it increase or will the acceleration decreases or the acceleration remain unchanged? What do you say? Okay, what do you say? Eidolon, what do you say? Isaac, what do you say? Acceleration increase. Okay, say acceleration. Do you agree? Acceleration increase? Yes, very good answer. Yes, acceleration increase. I want to see this. Acceleration increase. 1 mark. Okay, why? Okay, now why? Why you say acceleration increase? What causes the acceleration to increase when the cyclists bend their bodies? Joris, any idea? Yu Cheng, any idea? Ying Xing, Kai Xian, air resistant, momentum. Okay, don't just say momentum, don't just say air resistant. Okay, what is the effect on the air resistant when they bend? Force increase, Yu Cheng said force increase. So the answer, this is due to air resistance decrease. Okay, air resistance decrease, or you can say air resistance reduce, or it is due to greater net force. Okay, this one you have to add a bit. Net force increase. Okay, net force increase. So when the air resistance is reduced, mean the net force forward is increases. Okay, greater net force or net force increases. Air resistance decreases. Air resistance reduce. Okay, so I hope you're clear with this question, students. So, okay, now calculation. Okay, calculation. Now we calculate. Given the total mass of the cyclist and the bicycle in 5.1 are 100 kg. Okay, if they start from rest, meaning zero velocity, and achieve 10 meter per second, this is the final velocity in 2 seconds. Calculate the force applied. Actually, this is a very direct question as you do earlier. Alright, so find the force applied. So you are given M 100 kg, they give you U 0, they give you V 10. The T is 2 seconds. Find F. Okay, so what formula to apply when they give you all this? So how we relate all this? M, U, V, T, and F. Yeah, so the formula F equal MA, and A can be written in terms of V minus U over T. Alright, okay, give me the answer. What is F? Actually, this one no need calculator. Okay, from the writing, you can set what is the answer. 1000 divide by 2. Answer? Uh, 500 Newton. Yes, very good. Okay, answer 500 Newton. Okay, so what do you think about force? Can you deal with them? Okay, anyone, can you give a thought for 2.6 force? Boleh faham? Okay, who can deal with 2.6? Can you type 4 in the live chat? Okay, who can follow 2.6? Can you type 4 in the live chat? Thank you. So I give you a 2.7 impulsive force. Okay, impulsive force is the continuation from 2.6. All right. So stay tuned. You can go and drink water or you can go and wash your face for a while. So we will be back after this. Okay? 1 minit saja cikgu bagi rehat. Jangan keluar terus nanti masuk semula. Okay, Ming Min type 4, Ying also 4, Joris also 4, Zihui also 4, Ying Ling also 4. Okay, thank you student. And double dot also 4. Have you identify yourself? Ada tulis nama tak double dot? Who is this double dot? Have you identify yourself earlier? Okay, never mind. Okay. So I change my slide first for 2.7. So I hope you are there with your module as well. Oh, Sinwen. Okay, thank you, Sinwen. Okay. Okay. Okay, students. So if you're ready to go with 2.7, okay, can you type 1 in the live chat? Okay. If you're ready to go with 2.7, please type 1 in the live chat. Okay. So you can do some motion there to stay and to keep active. All right? Okay. So Joris ready to go. Sinwon also ready to go. Idolon also ready to go. Yenling also just sit. Okay, very good. Okay, now student, let us take a look on 2.7, impulse and impulsive force. So this is the two terms you must know very well. What is impulse? What is impulsive force? So there are two learning standard only. Okay, the first one to explain impulse and impulsive force, and the most important is to solve problem involving both impulse and impulsive force. Okay, so first let us take a look at this situation. Okay, look at what happened there. In an accident, in physics we call accident as a collision. All right, the force acted can cause severe damage, mean a very bad damage to the vehicle and injuries to the driver and passenger. So this is the impact of a collision. Okay, so to understand this, you have to recall what we have learned earlier in 2.6 force. Okay. Okay, next, look at the second situation. Okay. You are doing this during Sukantara, right? The long jump together with 100 meter. 100 meter and long jump to collect point for your house. Observe the athlete's legs upon landing. What can you say about it? Okay, can you observe the position of the legs when he landed on the sand? Is he landed with a straight leg or with bent leg? And why? Kenapa? Okay, so this is the two situation we can relate to impulsive force. Okay, during collision, student, during accident, what happened? A strong force acting in a very short time of interval are known as impulsive force. So what is impulsive force? A strong force acting in a short time. Strong force act in a short time. That is impulsive force, mean a sudden force acting during collision. Okay. Okay, so what happened? What is the effect? A car is brought to stop and experience a change in momentum. Okay. Okay, look at the front part of the car. Actually, the car is designed to have a crumple zone at the front. Okay. Why? This is to extend the time of impact during crumple zone is a soft made from soft material. So it is designed so the car will be crumpled or dented during collision as to extend the time of impact. So this is to reduce the impulsive force acting as an effort to minimize the damage to the car. So if you notice, if you look at the car, some part of the car is made from soft material and other part is made from strong material. For this reason, the soft material is to extend the time of impact, so it will reduce the impulsive force produced during collision. Okay, other than crumple zone, can you tell me where else the soft part in a car? Where else? Or which part is made from soft material other than the crumple zone? Okay, can you say your idea or your thought? Which part inside the car made from soft material? Anyone? It is in the front. Okay, the dashboard, for example, the dashboard. Okay, the dashboard is made from soft material. So if happen you collide when you hit the dashboard. Okay, so as it is soft material, so it will extend the time of impact. So it will reduce the impulsive force acting on you. So uh, it causes less or minimize injuries. Okay, on you. Okay, what about the second situation? Okay, so you see most athletes bend their legs upon landing or bend their knees upon landing. So why do they do so? Same reason, student. Okay, why do they bend their legs upon landing? This is to increase the time of impact or to lengthen the time of impact so that it will reduce the impulsive force acting on the body. Okay, hence reduce pain or the risk of injuries. Okay. Uh, Okay, then we go to the definition. Okay, impulsive force. As I mentioned, impulsive force is the rate of change of momentum. This is force in a collision or impact in a short period of time. So rate of change of momentum is a force. So force apply in a collision in a short period of time. Okay, and this is the formula. Impulsive force have the same formula. F equal mv minus mu divide t. Okay, the unit is in Newton. So mv minus mu is the change of momentum or called as impulse. What is impulse? Change of momentum. Impulsive force, rate of change of momentum in a short period of time. Alright? Okay. And the unit for impulse is Newton second. Okay, impulse is Newton second. Impulsive force is Newton. Alright? Okay. So this is for impulse and kilogram meter per second. For impulsive force, kilogram meter per second squared. Newton. Okay, so this is the difference between impulse and impulsive force. What is impulse? Change in momentum. mv minus mu. What is impulsive force? Rate of change of momentum in a short period of time. Okay? Okay, next. Okay. What is impact time, student? Look at this ball. It is bouncing on the floor. It is a soft ball. Okay, so impact time is the time of contact between the ball and the surface, between the object and the surface, the contact time. Okay, and if you see, when the material is soft, it has a longer contact time with the surface compared to a hard material. Hard material have a very short contact time with the surface. That's why it has high impulsive force. Okay. Okay, next. Okay. So this is how we understand this equation. Okay, and how we relate. If you look from this formula, F and T, they are inversely proportional. Impulsive force inversely proportional to the time of impact, which means when the time of impact longer or increases, how we increase? By bending our leg, by using soft material. So when doing that, impulsive force will be decreases. Okay? Aha. So this is the point taken from this equation. Number one, you can see change in momentum. What is change in momentum? Impulse. Final momentum and initial momentum. Directly proportional to the impulsive force. Okay. Second, impact time down here inversely proportional to the impulsive force. Alright, from the formula. So above is directly proportional, below is inversely proportional. Okay, next. Okay, so this one, now we relate to Newton's third law of motion. So we study Newton's first law of motion, which relate to inertia, and we study Newton's second law of motion, relate to F equal ma. So now this one relate to Newton's third law of motion. So what does Newton's third law of motion say? It say that for every action, okay, for every action, there is a reaction of equal magnitude but opposite direction. Okay, for example, look at this mortar and pestle. Okay, when you knock the mortar downwards, so there will be reaction from the pestle in the opposite direction. Okay, same with the footballer. Okay, this is the ball coming and there will be a reaction on the foot. Okay, action on the fall will causes a reaction on the foot. Same magnitude but opposite direction. Okay. Okay, what else? Where else we see? Okay, now this is the situation show to us how reduce impulsive force. This is application in our daily life. How to reduce impulsive force? So we can reduce impulsive force by increasing the time of impact. So in high jump, how do we increase the time of impact? By using a thick mattress here. Can you imagine if the jumper landing on the ground on a hard material, what will happen to him? I think that will be the last day he jump. Okay, he will never ever to jump again after that because he will broke all bones in his body. Okay, so one way using thick mattress to increase time of impact. So by that to reduce impulsive force. Okay, second, this one, bending. Sama juga ni, apply mattress. And for the storage of egg, okay, you can see the egg is covered with a soft styrofoam board here. It is covered with styrofoam. So all this is to increase the time of impact. So to reduce impulsive force. So prevent this egg from cracking, prevent this television from damage as well. Alright? Okay. And for the car, the crumple zone. Okay, now, in some situation, we need to increase the impulsive force, student. For example, if you want to crush a chili, okay, so we need to crush it with a very high impulsive, which means you have to reduce the time of impact. So how to reduce the time of impact? By moving the pestle at high velocity. Okay, high velocity. So it will come into the in contact with the mortar in very short. Chili or the onion in a shorter time. Okay, as shown here. When you apply the pressure, Where else we have to increase impulsive force? Di mana lagi? Okay, when you do karate, when you want to break a board, okay, with the karate, chopping, how to chop the board. So you have to move your hand very fast. So your hand will come in contact, uh, will have a short contact with the wood. So it will break the wood with a high impulsive force produced from that action. Okay, any karate do members here or taekwondo members here? So you apply impulsive force when breaking the wood chip in a karate do or taekwondo demonstration. Okay, now students, there is a few action in a sport we call as a follow through. Okay, follow through to deliver the ball in a long distance. This is normally applied in football, apply in cricket, apply in baseball, and also apply in golf. Okay, remember the sport: football, cricket, softball, and golf. Okay, so what is follow through? Follow through action in sports is an action after a strong kick. Mean after you kick the ball, your leg doesn't stop there. Okay. So the action is called as follow through. Same goes to this cricket. After you hit the ball, you see, you won't stop there. It's a continue with follow through action. So this will result a large change in velocity and it will travel longer distance. Okay. This is used to come out in the SPM. Explain follow through action in 5 all this point. Okay. What is follow through? It produce large impulse. So there are 2 marks for you here. And then as a result, the ball experience large change in momentum. Finally, the ball move at high speed and travel further distance. 4 marks. Alright? Okay, next. Okay, look at this example. Now we try to solve a problem involving impulse and impulsive force. Okay, first you are given a dart with this mass thrown with this velocity. It hits a board and it stick to the board with a final velocity is 0. Okay, so what is the impulse produced on the dart? So you have to highlight. The question asks you to find impulse. So what is impulse? Change in momentum. J is the symbol for impulse, change in momentum. So how we find impulse? Final momentum minus initial momentum. Okay, so substitute. This is the mass, final velocity, 0 because finally it ended on the board. So be this, the impulse is negative 0.4 Newton second. So Newton second equal to kilogram meter per second. Okay, mass and velocity. Alright. Okay. Now we check on the next question. Okay. Next question. Question 2. Okay, now find impulsive force exerted on the pins by the bowling ball. They give you a player strike pin with this mass 45.93 gram. Okay, at the velocity of 50 meter per second. And this is the time of impact between the ball and the pin, 0.005 second. So find the impulsive force. Okay, I give you 1 minute to find impulsive force. If you're done, you can share your answer in the live chat. Okay? Okay. First, don't forget to change the mass into kg. Alright? Okay, are you done, Jessin? Isin, Joris, Jingsheng, Poen, Sinwen, Ivan, Mingmin, Kaishen, Ji Yi, Junleong. Are you still there? Yushen, Bing Chen, Ying Xing, Xi En. Okay. So what's your answer? What is the impulsive force exerted on the pin? Okay. Okay. Jory say 459.3 kilogram meter second. Can you check on your unit, correct or not? Okay. Miming say 459.3 Newton, 459.3. Okay. Can you identify yourself? Are you just joining in? Siapa ni? Bagi tahu cikgu nama siapa. Go Ji Yi. Okay, 459.3 Newton. Okay, so the answer, this is the information given. So this is the formula for impulsive force. MV minus mu divide T. So substitution. Make sure the mass is in kg. Okay, this is important. Okay, then answer yes. Very good, everyone. 459.3 Newton. Okay, good job. Alright. Okay. So positive mean the force is acting in the same direction as the velocity. Just now the impulse is negative, right? So it show the impulse is acting in the opposite direction with the force apply. Alright. Okay, very good. Okay, now application. Okay, application. So for application of impulse and impulsive force, it can come in the essay question. Either a short essay or a long essay question. Short essay is 4 marks. Long essay question is 10 marks. Alright? Okay, so the first situation. High jumper lands on a thick mattress. As I mentioned just now, the thick mattress is used to increase the time of impact. So, to reduce impulsive force, hence to reduce injuries on the jumpers. Okay, second situation. Goalkeeper wearing glove to catch a ball. So a glove made from soft material, right? So why using glove? It is also to increase the time of impact between the ball and the glove. So to reduce impulsive force acting on the hand of the goalie. Alright? Okay. Reduce the pain. Okay, next situation. Okay, now to increase impulsive force by reducing the impact time. Okay, see the karate fighters there, how to break the wood chip, the wood chip. A karate expert can break a thick wooden slab with his bare feet that move at a very high speed. Why high speed? So that the impact time between the feet and the wood is shortened. So by this, it will produce a large or high impulsive force. So you can give it a try. Okay, you hit the wooden slab slowly and then you hit it quickly. Okay, there will be an effect. Or you can hit your table. Okay, boleh buat demo di sana. You can hit your table slowly. Okay, and then hit it quickly. So now you will feel pain, right? In your palm. Hit slowly, no pain because longer time impact between your hand and the table. Okay, when you hit quickly, short time of impact. So a high impulsive force acting on your head and the table. So you'll on your palm. Are you trying them? Who's trying? Type 2 for me. Who tried the demonstration? Hit your table slowly and hit your table quickly. Slowly mean longer time impact. Quickly mean shorter time impact. You will feel the difference, right? Hit slowly, so longer time impact. Small impulsive force acting, no pain. But when you hit quickly, high impulsive force acting. So you will feel pain in your palm or in your hand. Who's doing the demonstration at home? Type 2. Thank you for your cooperation. Okay, next. What is the next situation? Okay, this one. A massive mean very big in mass. Pile driver moving at a high speed, okay, is brought to rest upon hitting the pile. See, this is what happened in the construction site. How do they knock the pile downwards? Using a pile driver up here. This question come out in last year, last 2 years SPM 2023. Okay, 10 marks. So the time of impact between the pile driver and the pile is a long one. The driver is on top, is short. Okay, so it will produce bigger impulsive force, so the pile can penetrate easily through the ground. Okay, next. Okay, student, exercises. Okay, can you state two physics quantity which can produce large change of momentum or impulse? Okay, what is the two physics quantity can produce larger change of momentum or can produce larger impulse? Okay, what are they? The two physics quantity. Actually, you can find from the formula for impulse. The first one is the applied force, okay, and the time of impact. Okay, this one. Change in momentum. So, force and time of impact. Okay, next. Okay, this is example of essay question. Why the football player throw the ball as shown in the diagram. So we call this as throw in football. Okay, see how he throw the ball. Okay, look at his body position when throwing the ball. So this is related to follow through action. So how to explain follow through action? Okay, so first you mentioned it is a follow through action. 1 mark. So what happened during follow through action? It produced large impulse or large change in momentum. So what will be the effect? Okay, so the ball experienced a large change in momentum. So finally what happened? The ball travel further at higher velocity. 4 marks. First, follow through action produce large impulse. So ball experience large change in momentum and cause it to travel further distance at higher velocity. So can you see the sequence of the story of follow through action? So you can keep it in your mind. Follow through action produce large impulse. Ball experience large change in momentum. So finally it travel further distance at higher velocity. Okay, short story of follow through action. Okay, next. Have you ever heard this name, Mokhtar Dahari? Pernah dengar tak? He is famous with the Super Mok, our legendary footballer. Famous not only in Malaysia but also well known around the Asia. Okay. Okay, so what happened here? He kicks a ball with his force, 1500 Newton. Time of action between his boot with the ball is 0.01 seconds. See, very short. Okay, so the question is, what is the impulse delivered to the ball? So you highlight, we are looking for impulse. And then later, if the mass of the ball 0.5 kg, what is the velocity of the? So we are looking for two quantity here. First, find the impulse, mv minus mu, or ft, then find the velocity. Okay, how to find impulse? This is the information given. Force, time, and mass. Okay, how to find impulse, student? Okay, just now we calculate impulse, mv minus mu, right? But here they didn't give you u, they didn't give you v. So you can find impulse by this, ft. Okay, ft, the force and the time. Okay, from this formula, remember the formula for impulse? F equal mv minus mu divide t. Okay, this is the formula for impulsive force. When you bring t to this side, okay, so it will become impulse, mv minus mu. So this is impulse, change in momentum. Impulse equal to ft. So here we use f and we use t to find the impulse. Alright, so answer, what is the answer? Answer is 15 Newton second. Okay, or 15 kilogram meter per second. Alright, impulse. Okay, then what about the velocity of the ball? Okay, velocity of the ball. So now we can find the velocity. Are we looking for final velocity or initial velocity? Which one do you think? We are looking for final velocity after kick. Okay, so this is the impulse we calculated earlier, the mass of the ball. We are looking for final velocity. Initial velocity is 0 before the ball is kicked. Alright? Okay, so from here, can you tell me what is the final velocity from this calculation? Find V. Okay, press your calculator. Find V for me. Okay, I want to see who's the fastest in solving this. 15 equal to 0.5 V minus 0. Alright. So V equal to 15 divide 0.5. So answer is, yes, very good. 30 meter per second. So finally, the ball moved with the final velocity of 30 meter per second. Okay, good. Okay, next. Okay, now tennis. Okay, tennis also is one example of force which apply impulse and impulsive force. Okay, impulsive force. Okay, now you are given this diagram and this is the situation. Can you name me the name of this player, student? This is a well-known tennis player. Who is he? Player hits an oncoming ball. So this is the oncoming ball with a mass 0.2 kg and the velocity of 20 meter per second. Direction to the left, that's why it has negative sign there. Okay. Then after hitting the racket, the ball rebound. See, it rebound with a velocity 40 meter per second to the right. That's why it's positive. And the mass of the ball 0.2 kg. The time of impact between the ball and the racket 0.01 second. Okay, so what are we looking for here? You have to find, number one, find the impulse experienced by the ball. Second, find the impulsive force exerted on the ball. Okay, find impulse and impulsive force. Okay, come on, student. This is all your given information. Have you ever watched Prince of Tennis here? Japanese anime, Prince of Tennis. Okay, what's your answer, Joris? Uh, Sin Eun, Ying Sing, come on, Bing Chen, Yushin. Okay, what is the impulsive force and impulse experienced by the ball? Okay, if you're done, again, share your answer in the live chat. Okay, do you have any questions so far? Or any part you are not clarified with? You can type your question in the in call messages or in the live chat. Okay, no problem. Please don't be shy. Or later you can PM me in Telegram. If you feel shy to ask here, then you can ask me personally in the Telegram. Alright? Okay. Okay, are you done, student? Let us check for the answer. So for the impulse, okay, so this is the formula for impulse. J, impulse. MV minus MU. Since they give us U and V, you can use this MV minus MU. If they didn't give us V or U, you can use a J equal to FT. Okay, it's the same way. Okay, so we substitute mass of the ball 0.2. Final velocity. Please be aware with the positive and negative sign. Okay, if you look at this diagram, okay, if I zoom it for you, okay, to the left, negative 20. To the right, final velocity, positive 40 meter per second. Alright, okay. So our impulse is 12 kilogram meter per second or 12 Newton second. Okay, and for the impulsive force, okay, this one you divide with time. So 12 divide with the time 0.01 second. Easy. Answer 1200 Newton. Okay, 1200 Newton. Okay, so I hope you are not confused how to find impulse and how to find impulsive force. Okay. Okay, next. Okay, next, formative practice 2.7. In your textbook on page 69. Okay, look at the first question. We have a car collision test. Okay, with a mass 1500 kg. The car hits the wall with this speed 15 meter per second and it bounced back with this speed 2.6 meter per second. So this is the initial velocity. This is the final velocity. So when bounce back, opposite direction. Okay. If the collision time is 0.15, calculate the impulse and impulsive force acting on the car. Okay. So this is similar to our previous question. Okay, so initial velocity, it doesn't say the direction, right? So you can take the initial velocity as positive and once it rebounds, okay, must put negative there because move opposite direction. Okay, so find the impulse, find the impulsive force. So what is our impulse, student? MV minus MU. Substitution. Okay, answer negative 24, negative 26,400 Newton second. Negative means the impulse is in the opposite direction with the net force applied. Okay, now for the impulsive force. Okay, impulsive force. Okay, so you can write this equation for impulsive force. So you can take this value. No need to substitute again because we have calculated the impulse earlier. So you just take the value, divide with the time of impact or time of collision 0.15. So answer negative 176,000 Newton. And the direction indicate opposite direction to the initial velocity of the car. Okay, simple, right? Question number 1. Can you understand question number 1? If you do, type 0. Okay, if you understand the solution for question 1, type for me 0. Alright? Okay. Okay, very good. Thank you, Sinwen, for your response. Ivan, thank you for your response. Ming Ming, Ying. Okay, now we move to the second question. Okay? Are you still doing good there? Okay, I hope you still have the energy. We are about to finish 2.7. Okay? And 2.8 will be very short. Okay? I promise to you. A football player kick a ball with this mass 450 gram. With this force 1500 Newton. Contact time 0.0. Again, find the impulse. 3 second. Find the velocity of the ball. So we are looking for two things here. First, the impulse when the time 0.08 second, and then find the velocity when the time is 0.013 second. Alright? Okay. So this is optional, but I advise you will be clear which formula to apply in the solution and what are you looking for. So we are looking for impulse and finally velocity when t 0.013 second. Okay? Okay, next. Okay, so find the impulse. How to find impulse? Okay, how to find impulse here? Okay, they didn't give you V, right? You have U. Impulse equals to Ft. Okay, because F is given, T is given. So impulse is 12 Newton second. 12 Newton second. Okay, done. Second, find velocity. How to find velocity? Okay, when time 0.013 second. Okay, so this is the formula for impulsive force. Okay, so now, okay, so this is the force given 1500. This is the mass of the ball since we are looking for V, right? Okay, so this is the time 0.013 second initially before kicking. So can you solve for V and tell me what is the answer? Solve this equation. What is the final velocity when time 0.013 second? Okay, are you done pressing your calculator? So how to do this? 1500 multiply 0.013 divide 0.45. Simple. Answer? Okay, so your answer is yes, 43.333 meter per second. Who get same answer with teacher? Okay, type 7. Okay, type 7. Who get same answer with me? Type 7. CR7. Alright. Okay, student. Alright, next. SPM practices. Okay. So actually, I recorded this video on my own. I do the demonstration on my own in my living room. I drop a glass on top of my carpet and I record for demonstration. Okay. Yeah, very good. Thank you for your response. Okay. When a porcelain cup fall onto a concrete floor. So first, the glass drop on the floor, concrete floor, hard surface. Okay, it breaks in fall onto a concrete. Actually, when a hard surface, we understand earlier when an object fall on a hard surface, the time of contact is short, which means high impulsive force is produced. And when the same object fall on the soft surface, so the time of impact or the time of contact is longer, producing lower or smaller force. It say explain why the glass does not break. 4 marks. So how to get 4 marks, student? How to get 4 marks? So number one, you can tell the hard surface of the concrete floor result in a short time impact. Okay. Second, impulsive force produce high and then you talk about the soft surface. The soft surface of the carpet increase the time of impact or the time of contact. So by this, the impulsive force acting on the porcelain cup reduce. So it does not break. So where is the point here? Hard surface, short impact time. Impulsive force, high. Okay, next, soft surface, increase time of impact. So, mm, impulsive force, reduce. Okay, increase mean longer, longer time impact. Okay, next. Okay, this one. Okay, SPM 2023 example of questions. Okay, we have a pile driver, a pile, and a crane. Okay, for this question, you can find in section C. They give you the aspect, so you have to write based on this. But in some question, they never give you aspect. So you have to think on your own what aspect you want to explain to get 10 marks. Okay, so here we have a pile planter used in construction site. You are required to modify the planter so the piling work well it be more efficient. So your explanation must be on the mass of the pile hammer, mean must use bigger mass or smaller mass. The maximum height from the pile must be high or low. The hardness of the pile hammer, hardness must be high or low. Engine power must be high or low. Shape of pile, how the shape, oval shape, cylinder shape, sharp shape, or what shape. All right, so we try. So you are recommended to answer in a form of table for 10 marks essay question. Okay. The first column, your suggestion or your modification. Second column, your reason or explanation. So what do you think about the mass of the pile driver? Must use big mass or small mass, student? Big mass or small mass? Which one? So definitely we are using big mass. Mass of pile hammer must be large. Okay, must be large. Or you can say large mass of pile hammer, big mass of pile hammer. Alright, why? So can provide large force to bury the file. Produce large force. The bigger the mass, the bigger the force. Okay. Second, maximum height from the pile must be high. Why? Why the maximum height must be high? So this is to have high. So it will fall down with high velocity, or it will have high potential energy, or it will move down with high kinetic energy. All right. So the maximum height will determine the energy or the velocity of the pile driver when it fall. Next, okay, the hardness. The pile hammer must be hard. Hard. Don't use a soft pile hammer. Why must be hard? Remember, so to create a short time impact. Thus to produce high impulsive force to knock the pile penetrating into the soil. Alright. So next aspect, the power engine must be high. Okay, the power engine must be high. Why must use high power engine? Think logic. Why must use high power? So there will be more piling work can be done at one time. Okay, when you have more power, you can make more work at one time. So we can do more piling at one time. Alright. And finally, the shape. The shape of the pile must be sharp at the end. Or you can say the pile must have a nail shape. Nail shape, bentuk paku, tajam. Okay, at the end, at the nail shape or sharp at the end. Why? So that easy to bury, easy to penetrate the ground, or create high pressure due to small area. Alright. So this is all the suggested answer for you to gain 10 marks for this essay question involving a pile driver in a construction site. All right. Okay. So you can screenshot or later you can refer back to the video or you can refer to the complete answer of this module I share in your Telegram group. All right. Okay. So essay question number 10 is actually easy to score if you know how to write the the point. No need to write a very long sentences. Enough to put them into table. All right. Okay. So that's all for 2.7. Okay, now it's readily 10:55. I would like to ask you a question and please answer me frankly. Do you still have energy to continue with 2.8? Continue in the next another extra class. Okay, what do you think, student? Cikgu boleh saja kalau nak teruskan. I have no problem. Wait, I have 13 slides only for weight. You want to continue? If you want to continue, you type yes. Okay. Then this afternoon, this evening, tonight you can study for biology. Tomorrow you're sitting for biology, right? Okay, so I think we continue, yeah, because I only have 13 slide for wait, very short. Okay, thank you very much, students. So, without further ado, but before that, are you clear with 2.7? Later, if you have any problem, please just ask me in Telegram. Okay, no problem. Okay, please don't be shy as we are learning. So, I share to you my third slide on wait. Haha. Okay. So here they are. Wait. Okay. Okay, wait. I'm giving up on biology. Why giving up on biology? Please don't give up on anything. It's just the beginning of your journey. Okay. Take your time. I think you didn't find the pace first. Once you find the pace for biology, you find the pace for chemistry, you find the pace for physics, even for sejarah or bahasa, you will do it right. Okay. Give yourself sometimes. Same. Yeah, also the same. Okay. Find the motivation. How to excel in biology, how to excel in bahasa, how to excel in physics. Okay. Uh, just take your time. Okay. Don't give up, yeah. Okay. So are you ready? Okay. Let us continue with weight. Okay, student. Okay. What is weight? This is the final content standard on chapter 2, 2.8. Weight. All right. Okay. There are one learning standard only. That's why I said that's why I only have 13 slides. Okay. Describe weight as the gravitational force acting on an object. So when they ask you what is weight, so it is gravitational force acting on an object. What is gravitational force? Weight of an object. Simple. All right. Okay. So this is the formula for weight. W equal mg. W equal mg. And students, if you notice, I don't know either you have seen this in lower form before. This is a few example of measuring instrument which we can use to measure mass or weight. Okay, so we have A, B, C, and D. Can you tell me which one is used to measure weight? Some of them are used to measure mass. Some of them are used to measure weight. Which one do you think is used to measure weight? Type A, B, C, D. It can be more than one answer. Okay? Mhm. A is triple beam balance. B is lever balance. C is spring balance. And D is compression balance. So which one do you think is used to measure weight? Uh, Okay, anyone would like to give a try? Okay, which one? Answer is spring balance and compression balance. Triple beam balance and level balance are used to measure mass. Okay, spring balance and compression balance are used to measure weight. Okay, what is the unit for mass? We measure mass in a unit of kg, yes, kilogram. We measure weight in a unit of Newton. Okay, gravitational force, Newton. Okay, very good. Okay, now this is the comparison between mass and weight. What is mass? Amount of matter in a body. What is weight? Gravitational force acting on a body. Our mass is constant wherever we go. It's always the same. But our weight changes with the gravitational field strength on that place. Okay. Third, mass is a base quantity and also a scalar quantity. It has magnitude but no direction. Weight is a derived quantity determined from mass multiply gravitational field strength. And it is a vector quantity. It shows direction. Okay. And for mass, the symbol is M, unit is kg. For weight, the symbol is W, unit is Newton. So I hope you are clear with the definition, with the comparison between mass and weight. Alright? Okay. Now, student, example. Okay, same block, 2 kg. On Earth, its weight 19.6 Newton. On the Moon, it is weight 3.3 Newton. Okay, the same box. Okay, in a deep space, no gravity, zero gravity, it's weightless, 0 Newton. So the weight of an object is determined on the gravitational field strength on that places. Alright? Okay, same. Astronaut. Mass, wherever he go, always 84 kg. Earth, Moon, or in the deep space. But on Earth, its mass about 840 Newton. On Moon, less, 6 times less, 140 Newton. On deep space, 0 Newton. Why? No gravitational field strength there. Alright. So according to Newton's second law, we learned earlier, this is Newton's second law, F equal to ma. So talking about wave, this F can be represented by W, gravitational force. And acceleration can be replaced with gravitational acceleration, G. So we have W equal mg for weight. Okay, W equal mg. Okay, so what is M? M is the mass, W is the weight, and G is the gravitational field strength, Newton per kg. Okay, on Earth, the gravitational field strength is 9.81 Newton per kg, similar to gravitational acceleration, 9.81 meter per second square. It means that for every 1 kilogram on Earth, experience a force of gravity of 9.81 Newton. For each 1 kg of our mass, there is a force of gravity of 9.81 Newton pulling us towards the center of the Earth. Okay, so this is how we understand gravitational field strength. Alright, okay, next. Okay, look at this astronaut. The question there, what is the weight of the astronaut suit on Earth and on the Moon? Okay, can you imagine the mass of the suit is 81.65 kg. Can you bear wearing a suit 81.65 kg? Okay. So the question asks you to find the weight of the astronaut suit on Earth and on the Moon. So how to find the weight on Earth? So W equal mg. Mass multiply gravitational field strength. So on Earth, this is the weight of the suit, 800.9865 Newton. Okay. When he goes to the Moon, what is the weight of the suit? Okay, so on the Moon, we understand the gravitational field strength is 6 times less. 6 times less compared to the Earth. Alright, so it is 133.4 4978 Newton. Okay, lesser. It will be less weight on the moon. 6 times less. All right. So this is how we calculate weight. W equal mg. Okay. Next. Okay, this one. Exercise, student. So they give you this triangle of weight. Weight W on top equal to m multiply g. Okay. Can you find the weight of a helicopter when it land on the peak of a mountain where the gravitational field strength up there is 9.78 Newton? Okay, fine. Find the weight. Very fast. Find the weight. This is the mass. Okay. So equation W equal mg, mass 600, gravitational field strength 9.78. So it will give us 5,868 Newton. Okay? Simple, right? Okay, next. Okay, this one. Now object 10 kg. This is the weight 150 Newton at planet X. Okay, planet X. First question, find gravitational field strength of planet X. Second, is planet X larger than Earth? Give reason for your answer. Okay, B is K, but okay, first find A. It's a straightforward question. Again, our equation W mg. W is given, right? 150. By here we okay, G 15 Newton per kg. Direct question, student. Okay, last. Is planet X larger than X? What do you think? Planet X larger than Earth? Yes or no? And why do you say so? So, as the gravity of the planet is higher than Earth, so the mass of the planet is larger than that of Earth. Earth is 9.81 Newton per kg. Planet X is 15 Newton per kg. So as the gravitational field strength is greater, so from here it tells us planet X has a larger mass compared to the Earth. Alright, from this value, 15. Earth 9.8 larger mass compared to the Earth. Okay, last question, question 3. Okay, last question on weight. We have feather and ball, student. Okay, this is a stroboscopic photograph for a feather and a marble. Okay, stroboscopic is a device we use to freeze the motion of a moving object. Later, I will show you in the lab how we use a stroboscopic to freeze the motion of a falling or moving object, so we can picturize the changes in position as they are dropping from a height. Okay, this is happen in a vacuum. Okay, so first question, define mass. Do you remember from the comparison just now? What is mass? Amount of matter in a body. Amount of matter in an object. Okay, mass. Okay, next. Okay, now comparison as we look before. Compare the mass of the feather and the marble. So how you compare mass of feather and marble? So you can say mass of marble greater than feather. Mass of marble greater than feather. Okay. Compare the time taken to reach the bottom. Okay, from this photograph, what can you say about the time taken to reach the bottom? Same or not? So, same, right? So, we say same. Comparison can be same, can be different. Okay? It doesn't mean have to be different all the time. So, from this photograph, we understand they reach the bottom at the same time. So, we just say same, or you can say equal. Okay? Now, state how the mesh affect the time taken to reach the bottom. Okay, does the mesh affect the time taken here to reach the bottom? Yes or no? It does not affect. Okay, from here we understand mesh does not affect the time taken to reach the bottom. Okay, name physics concept. Describe the situation. Yeah, no. Yes, very good. Answer no. So can you name the physics concept? Describe. Okay, what happened to the feather and the ball here in vacuum? What do we call this concept? They fall at the same time, regardless of their mass. In vacuum, they reach the bottom of the same place. So what is the concept? We learned before in class, remember? 2.3. Object falling in vacuum. Reach the bottom. Yeah, very good. This one. I want to see this. Yes. Free fall. Answer, free fall. Very good. Okay. Yeah, free fall motion. Very good. Free fall. Okay, can you name one physical quantity that caused the feather and the marble to fall? So now they fall due to what? In free fall. They fall due to what, student? Free falling object are falling due to what? This is the meaning of this question. Name one physical quantity that causes the feather and the marble to fall. So when they free fall, okay, your friend say gravitational acceleration. Another one say gravitational force. This one gravitational force. Okay, which one? Answer gravitational force. Answer ini salah bukan gravity, gravitational force. Okay, answer gravitational force. Okay, they fall due to gravitational force. And they fall with the Earth gravitational acceleration 9.81 meter per second squared. Alright? Okay. Very good. Okay. So, that's all about weight, student. As I promised to you, it will be a short one. Okay? So, are you okay with weight? So just understand what is the comparison between mass and weight, and what is the definition for weight? Weight is gravitational force acting on an object. And how to solve a problem involving wave by using the equation W equal mg. So I would like to go and feed you now. Dia dah lapar, sudah lama tunggu. So I guess you can go and continue with your next activity. Have a great lunch. And I guess that's all for now. So I have covered the whole chapter for chapter 2 and 3.1 and 2 as well. So please spend your time to do revision for your incoming exam. Any problem you can always ask me, either in school or from Telegram. I will be in school tomorrow. Or Aki tomorrow. Okay. Again, thank you very much for your effort. I really appreciate your presence here. So happy resting time and good luck for biology tomorrow, student. Okay. Please try your very best. So I wish you all the best for biology and the rest of your paper in your examination. Okay. So bye bye and thank you students. You can have a rest.
Dibawakan kepada anda oleh Akademi YouTuber.